Hey, hello and welcome to today's GFG problem of the day. Hope you all are doing well. So let's see today's problem, recursive sequence. Okay, so the problem will give us a n. What the problem is saying is they'll give us a number n, and we want to have the calculation in this way. For example, n, right? So 2 into 3, right? For example, if n equal to 5, right? So what they're expecting is, let's first write it: 4, 5, 6, 7, 8, 9, 10, 11, 12, sorry, 13, 14, and 15. So if you observe here, what we want to do is we want to have calculation in this way, in this fashion. Okay. And we want to return the sum of all these multiplications, and we want to return the answer. Okay. Now, if you see when n equal to 5, there are how many terms or how many iterations? 1, 2, 3, 4, 5. There are 5 multiplications for which we need to add, for which we need to do the addition. Okay. So there are 5 iterations. And for each iteration, if you observe, for example, for the first iteration, there's one element only. For the second iteration, there are two elements. For third iteration, there are 3 elements. For fourth iteration, there are 4 elements. Likewise, and five iteration, there are 5 elements. Okay, there are 5 elements. So what we want to do is let's first write a so this is the second observation, right? For each iteration, there will be the equivalent multiplication of the numbers. Okay. Third observation is, if you see this number, right, it is starting from 1, and it is every time it is getting incremented, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, like this. Okay. So there are 3 observations in the pattern. Okay. So first let's write a pseudocode for this outer iterations, right? So there will be n iterations. For example, if you write for I equal to 1 to n, this is for the outer iteration, right? And then for each, if you observe, right, what you want to do is we want to have the multiplication of these numbers according to the I. So if I is 2, we want to have 2 numbers. If I is 3, we want to have multiplication of 3 numbers. So what we'll do, we'll have one more internal for loop, j equal to 1 to I. Why till I we are moving? Because for each I we want to have those many number of multiplications, right? That is why till I. Okay. Now what we'll have in this, we'll take one variable multiplication, right? As we want to do for each iteration, do multiplication of these numbers, right? Multiplication will initialize with 1. Now we want to have one more variable counter, which will have the this track of these numbers, right? Track of these numbers. So we'll have one counter variable. Now what we'll do for each I, right? Right? We'll have j equal to 1 to I. So we'll do multiplication equal to multiplication into count variable. Okay. And what we'll do is we'll increment the count as well. We'll increment the count. So if you take this example, right? So I equal to 2 in this case. I will be equal to 2 in this case. So we'll run this internal for loop 2 times, right? Internal for loop 2 times. So after first iteration, right? So when during the first iteration, the count was 1, right? Count was 1. So we had multiplication, right? This in internal for loop ran once, right? Because I was 1 here, right? And we'll have one more variable, let's say sum equal to 0, right? To add all these multiplications, right? So we'll have sum equal to 0 initialize, right? So after each multiplication operation for each iteration, we'll do sum equal to sum plus multiplication. Sum equal to sum plus multiplication, right? So what we are doing here is, see, first I is going to be 1, right? I is going to be 1, count is going to be 1. So this loop also will run one time, right? I 1 to 1, right? So multiplication contains 1. So multiplication, what it will be, mul equal to 1 into what is count? Count is 1. So multiplication will be 1, right? And count will increment to 2. Now count has become 2. Will increment count to 2, right? Here, right? Then I turns 2 here. I turns 2 now. So this loop will run twice, right? So what the operation will be? Mul again will be initialized with 1. 1 into count, right? What is 1 into count? Equal to 2, right? So let's have multiplication here as well, right? So multiplication variable will contain 2 now. So it is containing 2 now. And count we are incrementing here. So count will be 3, right? Again, this for loop will run, right? One more time, right? So mul contains what? Mul contains 2 now. So we are going to multiply with count now. So 2 into 3, right? 2 into 3, which gives us 6, right? And then we'll increment count as well. 2, it will be 4 now, right? So this iteration is done. One iteration is done. We have multiplication result in this for one iteration, and then we are incrementing the count. Again, I will be incremented this time, right? We have counter equal to what? 4, right? In this way, the internal for loop will run thrice, right? Will run thrice, and each time we are going to increment the count. We're going to multiply with the mul. Mul is going to, this variable, it is going to be initialized in each iteration. Okay. And final result will have in sub. So this is a pseudo code. Let's quickly see the actual code I've already implemented. So here, if you see, as answer can be very large, return the answer modulo. So the result, right? It can be very large. So the problem has asked us to do the modulo operation. Okay. Modulo with 10 raised to power 9 plus 7. Okay. So simply I have already explained this. This outer iteration, we are in, having this multiplication variable for each iteration, right? And it will run I times this internal for loop count. We already have count one initialized, and we are having multiplication. Then we are incrementing count, right? And finally, we are having the sum result. We are adding the multiplication result into the sum result, and we are also doing mod operation over here, right? Because the number can be very large. Okay, mod operation here, and here as well. C++ code is almost same. It's completely same. Only the difference is here we are returning long. The sum type is long here. Okay, so let's run the code. So yes, today it was an easy category problem. Okay, so yes, it is accepted. I hope you've got the solution. Please subscribe to my channel and like the video. Have a happy, healthy, and a great day. Thank you so much.